root, whatever. These are running with maximum privileges, and that central server in the middle is responsible for the security of absolutely all of them. If you think about agents as you would an SSH server, imagine a central machine in the middle that has all the keys for every single one of the machines there. Same idea. And then connected to all these are tens of people running admin UIs. They might be web browsers, they might be custom Windows applications that essentially pull data out of the agents and send commands back to the agents to tell them what to do. These are like the bot masters in their UIs, essentially the exact same idea. And if you want a picture, which actually might work, just to put that into a picture, right in the middle there you have a management server. It doesn't particularly work, but you know, agents on desktops, agents on servers, these things all connect to SQL databases to hold the actual data that they're using. And then you have, you know, Win32 management interfaces or web-based management interfaces. And the thing I'm trying to convey by having this picture here is that there are a lot of different ways to attack these systems, a lot of different places that you can start with if you want to actually start trying to break in and taking over 10,000 machines with a single exploit.
I think another thing about that is also remember internal networks. You don't have the same level of network segmentation, the same level of firewalling. So even though you saw a database there and you saw a management server, you may be able to connect to either one of those directly from anywhere on the internal network. I'm not saying every network's like that, but more are like that than you'd think.
This slide's totally just flat out not going to work, but I think you guys get the idea of one box in the middle, tens of thousands of machines that you get if you take over that single box, and what the actual penalty is. And remember, enterprises have more than one of these systems installed. You know, some places may be using Unicenter, some places may be using some totally different agent-based management system. And each one of them is essentially a botnet pre-installed for you by IT, and each one of them is a target for attack. You can go over, you know, you can go after multiple ones and get disjoint sets of machines. So let's start with the first and simplest possible way to attack these things. The agents themselves are waiting for connections from that central management server. So can we attack the agents directly? Well, yes, we can attack the agents directly. The agents are bound to a port. They're running clear text protocols. It's not SSL. There's no certificates being exchanged whatsoever. The only defense that these things have is they're running protocols that aren't documented. So the only defense they really have is that, you know, we're assuming that people aren't going to go and look on the wire or put a plugboard proxy in the middle and actually look at the protocols being run over that connection. And what are the types of things that we find when we're attacking the agent directly? Well, how about a protocol in which the very first thing you do in the protocol is send the name of the server connecting to you? And how about, let's do the time warp again, go back to 1995, and it's a Stack Overflow in the name. It's that simple. It's like the equivalent of a Stack Overflow in the GET handler and a web server. I wish I could say that that never happens anymore, but on internal applications, on a particular storage vendor, buffer overflow, stack overflow, and the GET handler of the web server. It's the exact same idea in the agent. Now, remember, if you take over one agent, you're now in a position to talk directly to that central management server. That central management server is going to talk to you. Aaron Bachman, are you making fun of me? Close my laptop. So one way we can attack these things, one place where we found vulnerabilities where there are very popular agent-based management systems where we can connect to the agents bound to a port, and we can send them traffic that's going to trigger a Stack Overflow, and we'll take over the agent. If we're in a position to talk through filters or whatever, talk to that central server, the exact same problem actually occurs, right? There are a variety of cases in which the agents are designed to connect directly back to the server to post, you know, a new update, something new happened on that. Same type of problem. The vulnerabilities here aren't that interesting. It's the fact that these systems exist that you can attack. That is interesting here. So you can do the exact opposite, which is just connect to the server directly, and there are vulnerabilities that you can trigger there too. Specifically, look for things like Stack Overflows. Look for strings and fields that you can look for places where there's a string field and you stick a semicolon and a command after it, and the command gets expanded and run as if it was running through the Bourne shell. Happened with one of the major agent-based management systems that we looked at.
So another interesting form of attack that's, I wouldn't say it's unique to this type of architecture, but it's definitely something that's different than your standard kind of web-based client-side attacks, is that with agent-based technology, you're going to have management servers. You may even have the admin UIs connect directly to the agents periodically. It may be automated, but it's guaranteed that at some point you're going to be, if you control an agent, you are going to be in a position to attack the server when the server tries to pull information off of you or make some kind of communication request with you. So unlike in web environments where you have to be opportunistic and try and get people to wherever it is that you're trying to launch your attack from, or you have to compromise a server that's popular and extend that way, you are guaranteed in this situation that at some point in time, you're going to be able to attack that management server, you're going to be able to attack that admin UI.
And this slide got clipped, but at the bottom of that, we're coining a term for this type of attack. Client-side attacks in general, things like browser vulnerabilities. Actually, browser vulnerabilities are taken pretty seriously right now, but in a variety of situations, the client-side attack is kind of like a stepchild to the direct taking over the server. We have a new term here, we're calling them captive client-side attacks, and they occur a lot in agent-based management scenarios. And a captive client-side attack is simply a case where it's a client-side attack in that you're attacking the response to a request that somebody else sent you, but you're in a situation where it's deterministic. You are guaranteed to get that particular request. You've taken over an agent, and that agent is going to get the request that's going to come in, that's going to expose the server to the attack. So it's a captive client-side attack in that you're guaranteed to be able to pull it off. You don't have to coerce the server to talk to you. So are there situations in which if you take over an agent and the management server connects back to you, are there buffer overflows in the responses there? The answer to that question is yes, there are buffer overflows and the response is sent back to market-leading agent-based management systems.
So while something got cut off here, there's something I wanted to explain about the format of these slides. And again, we'll make sure that for anyone that can't see them, that you'll get copies of them, find us afterwards. But inside of each of these slides, we're going round by round through. You'll also see that there's kind of an anonymized advisory mentioned at the top of it. As Tom said, we're probably sitting on 30 plus security vulnerabilities inside of the space in general, with as many as 15 to 20 inside of one company alone. So what we're trying to do is we're trying to let you know that these aren't just things. We're not talking about this from just an architecture perspective, and these are the things you need to think about. We're saying these currently exist inside of enterprise management applications, and we know it.
So I know it's hard, right, for us to look at the slides and say, there are stack overflows here and there are heap overflows there and all that. But in general, I'm not sure how useful it is for you guys to see a hex dump on the screen of where an overflow is. It's more important to us that when advisories come out or when you look at this stuff, that you take the agent-based management systems, the central servers there, as extremely serious, high-priority targets inside of your enterprise. So here's another situation. This slide's really hard to read because of the fonts, but another vector of attack. The protocols themselves that are running there. Well, can we look at those protocols? If we can sniff, what kind of access do we get? Well, if we sniff the traffic between the agent and the management server, we get enough information to connect to the management server as any given agent, or vice versa. And we see all sorts of ridiculous authentication schemes. We found in a particular vendor a situation where we were able to connect to the management server, and there's a heap overflow in the connection message that you send. It's a 512-byte connection message they send with a fixed string in it. If that string gets too big, there's a straight-up heap overflow in it. And it's Windows allocator, it's game over, right? And we send it to them, and they come back with us, and they say, we fixed the protocol. We now authenticate when people connect to us. And the way that we authenticate is we make sure that we're talking not to an exploit, but to a legitimate agent running the legitimate agent software. And I'm like, well, how do you do that? And it's like, well, we look at a magic number inside of the connection packet, inside of the connection message, that only the agent ever sends. Anybody want to take a wild guess as to how large that magic number actually turned out to be? 1 byte. Anybody want to take a guess as to which byte it was in the packet? The first byte in the packet was how they determine whether or not they're talking to a legitimate agent and they should trust everything they say. Now, I know 32 bits because we also, another ridiculous situation with authentication, there was a vendor that actually did a crypto-strong authentication between the client and the server, but that crypto-strong authentication produced essentially a cookie, which was a 32-bit monotonic cookie. And if you had that, you could submit subsequent requests as that authenticated agent. And those cookies started out at 0, so you could just start at 0 and scan up from 0 to 1,000, and you were guaranteed to get all the logged in sessions. Remotely, blind, without sniffing. You just talk to the server and you try each individual one until the message comes back successful. And then you pretend to log in. Generally, The way we exploit these types of vulnerabilities, because these sound pretty complicated, our general strategy for exploiting vulnerabilities like this is we build a proxy. We build a plugboard proxy that runs in between the legitimate management application, the web console, or the Win32 management app, or whatever command line crap they use to command these things, right? And we proxy the application through it. And there's a point in the protocol where that exploit is exposed. And all we do is the same thing we did with iSCSI. In iSCSI, there's literally a bit in the header that if you set it, that bit essentially says, I'm logged in. And we found the market-leading iSCSI server honored the bit in the header without actually logging in. You're able to just get into the server doing that. And the way we exploit that is we write an iSCSI proxy that just takes the login messages and doctors them. So they always have that bit set in. So essentially what we get is a fully functional, legitimate client that has superpowers in that we've exploited it and then handed the connection back to it. Exactly what we do in this situation too. If I want to guess one of 1,000 cookie IDs, and then have a management client that can act as if it can log in as any user, that's how I'm going to do it. Is I'm going to write the client, or we did write the client, that just tries all those every time somebody logs in through that proxy.
And of course, just like perimeter applications, these applications are susceptible to all the standard implementation vulnerabilities that we've seen throughout the years. And it's even worse, right? Because a lot of times these applications were written years ago with even less security in mind, or no security in mind. So whereas stack buffer overflow, stack-based buffer overflows may be uncommon in applications we're all familiar with, on the internal network, common. Things like, as Tom was talking about, meta-character expansion, the ability to basically send in some data and have it get executed as a line inside of a Unix command shell, surprisingly common. So it was actually kind of fun for me because I got to take out basically parts of my my toolkit from like 1993, and suddenly that knowledge became useful again, whereas I thought I was just kind of slowly becoming useless. So it was very exciting. It's like all my skills from 93 on are completely valuable again.
And that's just to those of you who've lapsed. You can get right back in on internal apps. So you think that the web server that controls the server that owns 10,000 machines on your local network, well, that would be a pretty good web server, a pretty good web application. JDEE and struts and all the other cool stuff, right? You think it would be better than, for instance, WordPress, my blog software? No. They have what we call cosmetic security in a lot of cases. They'll have a login page, and then, like every other bad application from 1999, you can just skip the login, go directly to the page behind the login, and that stuff works. The difference here is that once you do that, you're now in command of 10,000 machines on the internal network. So one thing to look at in agent-based management software is the fact that all of these things now have web-based clients and web-based management interfaces, and none of these web applications are any good whatsoever. Don't even get started on cross-site scripting. Right? It's a lame finding compared to what you're going to be able to do. SQL injection works absolutely everywhere. Forced browsing works on these stupid applications. So our advice about the web-based management interfaces of the most popular agent-based management systems is to turn them off. They don't work well. So definitely part of the moral of the story is if you've got people that are using these things, lock them down tight. Only allow certain people to talk to that management server, at least on those ports. You cannot leave those things exposed on your network. It's too tempting of a target. Why would you waste your time trying to install Agobot across an entire network, breaking into machines?